Good afternoon, dear students. Today is our last practical lesson in this semester. It will be about the application of differential calculus. And today we will use we will calculate derivatives as well, but with the practical application. So first of all, let me remind you some information. So a hospital rule or a hospital rule. So it is some special rule that helps us to calculate limits in case of uh, the following indeterminate forms. So infinity divided by infinity and 0 divided by 0. So the limit of fraction of functions equals to limit of derivatives, or fraction of derivatives. This is the equation of the normal at specified point. So m0 with the coordinates x0 and y0. So the normal is the straight line that is perpendicular to the graph of the function. So just reminding you slope form of the straight line. So this is the slope 1 minus value of derivative at point x0. And this is the equation of the tangent line. So this is the line that is that touches at some point. And this is basically is okay. This is a normal line, a straight line. Any questions about this task? About theory?
No questions.
Okay, so let me start solving tasks. So the first, so we will use orbital rule for. Okay, I don't want to upgrade. So we will use orbital rule for calculating limits. By the way, I am not sure how to pronounce correctly because it is a French surname, so I don't speak French. Maybe anybody of you, but I'm not sure how to pronounce correctly different variants. Hospital, el hospital, and so on. So the following limit. So if I substitute 0, by the way, it must be minus. Yeah, minus here, and here is a mistake. Yeah, because if I substitute so 1 plus 1 minus 0, everything is okay. So 1 divided by 0, no indeterminate form. So it must be plus or minus. So 1 minus 1 minus 0 and divide by 0. So we have the following indeterminate form: 0 divided by 0. And now we need to differentiate this expression and eliminate the indeterminate form. So let's differentiate. I will do like this. So everything will be written in details for now. So both the numerator and the denominator. Okay, so 3, 2, and minus 5 here, and 2x. So what do we have? So 3 minus 2, so 1 minus 5, so minus 4, and divided by 0, it is actually infinity. So any questions about this task? It is quite simple. Okay, so moving to the next 1b. Calculating the following limit. Stop. It's like a spoiler. So 8x multiplied by cotangents of x. So the indeterminate form is the following. 0 multiplied by the infinity. So we know that cotangents of 0, so when x approaches 0, the limit of cotangents is infinity. So depending on, so either plus or minus depending on the sign. So we cannot use a hospital rule when we have the following indeterminate form. So we need to change to transform this expression a little bit. How to do it? Just remembering some properties of trigonometric functions. So cotangents equals 1 divided by tangents. And that's it. So now we can use it because incorrect a little bit. Yeah. Because we have such indeterminate form, 0 by 0, we actually can use consequences from the first special limit, but our task is to use a hospital rule. So this is the requirement. So differentiating the numerator and denominator. So 8 in the numerator, and what about denominator? 1 divided by cosine over cosine in power of 2 of x. And if I transform it, so if I eliminate so a lot of rows, so 8 cosine square of x. So the answer is 8, because the cosine of 0 equals 1. Any questions about this task?
No questions.
Okay. Well, let's solve one more example. It will be a little bit large. Yeah, Mikola, question?
Yeah, I have a question to the first for the answer. Limit approaching 0, 3e in power of 3, and so on. How we get infinity?
So if I substitute 0 here, 3 minus 2, so 1, then so 1, so minus 4 divided by 0. So it is so minus infinity even.
Yeah, I'm about it.
So have I answered your question?
Yes.
Okay, and now let's calculate, let's solve example C, if you don't have any questions. So it will be harder, and you will see that basically a hospital rule is not such convenient as it could be, because we will have to apply it a lot of time. So indeterminate form is the following: infinity minus infinity. So as well, we cannot use a hospital rule in such case. So we need to find the common denominator. First of all, so the common denominator is the following. So multiplying tangents by arctangents. Uh, and yeah, doing this action, performing these actions, and basically this is the uh, fraction. So, and now we have the following indeterminate form: 0 divided by 0. And now we can use a hospital rule. So now we will differentiate these functions and we will see that we will have to differentiate a lot of times. By the way, pay your attention that we don't differentiate the whole this fraction, but we differentiate separately numerator and denominator. So when solving your individual tasks, be attentive. So firstly, the numerator. So 1 divided by 1 plus x square and minus 1 divided by cosine square over x. So done with the numerator, and now we need to calculate uh, a derivative of a product, so that not is such a pleasant action, but we have to. Okay, so done. So differentiated, and now if we try to use so if we substitute 0, so 1 minus 1, 0, and here 0, 0. So again, the indeterminate form uh, uh, haven't gone away. First of all, let we simplify this expression. So let's eliminate a lot of rows. What's going on? So this, so eliminated. So cosine square minus this. Yeah, attention. So now everything is correct here, and now doing the same here. Well, now we can eliminate these expressions. That will be simpler. No, stop. So moving this here. And doing like this. So now we will differentiate again. Now let me maybe expand it because we use a lot of space. So let's save it just to see the whole solution stages. Now differentiating. Again, numerator and denominator. So, 2 cosines of x by sine of x. Remember that we differentiate composite function. Minus 2x. So done with the numerator. And what about denominator? So 2x multiplied by arctangents of x. And if we differentiate arctangents and multiply by this, so we will just receive 1. So now 2 cosine of x multiplied by sine of x and multiplied by tangents. And if we differentiate tangents, we will receive 1 divided by cosine square of x. So plus 1. So done with the denominator. Now let we divide both parts by 2. So let's simplify a little bit. And then we will check what's going on. So 2 cancel into here, and 1 remains. So now multiplying, so now substituting 0. So 0 in the numerator, but what about the denominator? So we have 1 here, so 0 divided by 1 equals 0. But maybe you agree that with using chain of infinitesimal equivalent infinitesimal functions would have been a simpler solution. But we have what we have. So the answer is 0. Any questions about this task?
No
Okay.
questions.
No questions. And by the way, pay your attention. So when solving your individual task, so make sure that, yeah, so important comment. In this, the first task, you calculate limits with the using infinitesimal equivalent functions, special limits, and so on. So no hospital rule in the task 1. You will use a hospital rule in task number 3. Not number 3, by the way, in the task number 4. So only here. So make sure that you do everything according to requirements. If not, so re-upload your answer, so solve again. So make sure that everything is according to requirements. Oh, I am sure that you understand it, but just to remind. So if no questions, let's move to the next task. The next task is stop. 0/2 infinity. Yeah, something yeah, incorrect here. Okay, we will need to. Yeah, but by the way, minus sign here. Minus. So be careful with the signs. 0/2 in infinity. Yeah, it is a mistake. Okay, the next task is to write down the equation of the normal to this curve at point x equals 1. So, first of all, let's differentiate the function. To x plus 3 by 2x minus 3 prime. So, doing the next. So this will be in power of 2, and now differentiating the and now calculating the numerator. So 2 by 2x minus 3 minus 2 multiplied by 2x plus 3. Now expanding brackets and simplifying what we can simplify. Let's do double check. 4 minus 6, yeah, minus 4 minus 6. Okay. So minus 12 divided by this square. Now we are calculating values. So, by the way, let's just believe these recordings. So, yeah, 2 plus 3, so minus 5, and here minus 12 for y prime. And basically, this is the equation of normal point. So, just equation of the straight line passing through the point 1 and minus 5. So y plus 5. So just reminded you analytical geometry. And so k equals k equals 1 divided by minus y prime. Oh yeah, so minus 1 divided by y prime. So 1 over 12 divided by x minus 1. And this is actually the normal line. Let me check it here. So let's just see the geometrical interpretation. So 2x plus 3 and 2x minus 3. And y plus 5 equals 1 over 12, x minus 1. And something is incorrect. Stop. Yeah, this is normal. So not tangent, but normal. As we can see, it is perpendicular. And by the way, what about the straight, the tangent line? It looks like this, so it is perpendicular to the normal. But we will find the equation of the normal straight line, or with the tangent straight line in task number 3. Any questions about this task?
No questions.
Okay, no questions. So the next function, it's just a parabola. So no fractions, no pains. So, yeah, and prime, of course. So 2x minus 5. So y 0 equals, so 9 minus 15 plus 8 equals 2. And y prime is in at point 3, so 6 minus 5 equals 1. So y minus y y0 equals okay, so let's just substitute. So y minus 2 equals 1 by x minus 3. So actually we can just eliminate 1 because no need, and even it is convenient to write in the slope form. And let's check. Here it is, and y equals x minus 1, and here it is. So 3 2. So this is the straight, so this is the point when where this straight line touches parabola. Okay, maybe any questions about this task?
No.
Okay, and now we will investigate. So we will investigate functions for monotonicity and find an extrema. Let me remind you that extrema are these are points at which derivative of a function is 0 and the function reaches maximum or minimum values. So first of all, we need to calculate the first derivative. Yeah, and by the way, reminding you, so when derivative is 0, the first derivative, when the first derivative is positive, the function increases. So positive, it means that function increases. When it's negative, function decreases. So now let's differentiate. Pay attention that x equals minus 3 is discontinuity point, so pay attention, but the function and it's, well, the derivative, yeah, well, it won't change the sign, but anyway, pay attention to it. Yeah, it won't change the sign because power of 2. So 2x multiplied by x plus 3 and minus x square plus 7. So now expand in brackets. Uh, 2x squared plus 6x minus x squared minus 7, and continuing simplifying. X squared minus 6x minus 7. So and now we need to solve the following equation. So when y prime equals 0, so we need to find critical points. So critical points are points at which derivative of function either 0 or it doesn't exist. It doesn't exist when x equals minus 3, so take it into consideration. Now let's expand it into, so let's factorize this expression. So with using weird theorem, if we can, so basically, so 30, so what about discriminants? 36 plus 28, and it seems that, 64, yeah, so discriminant can be calculated. So 3, so minus 6 and 7. Oh, minus 6 and stop, minus 7 and 1. So x minus 7 and x plus 1. So verifying. Stop. Vice versa. So x square, so minus 7 and then 7x minus x. So now correct. So factorized it. So at which point y prime equals 0. So it equals 0 at point minus 7 and at point 1. And y prime from minus 3 doesn't exist. So now let's solve it with the integral method. So we just need to find when the function is so we need to investigate signs of the prime, y prime. So stop x. So here y prime, and here we will write y. So which points are interesting for us? So minus 7, and then minus 3. So here it is, and 1. Yep. So pay attention that minus 3 is excluded. So investigating signs. So what we choose, for example, 2. So it will be positive. Here will be negative if we choose 0, for example. When passing this point, because of power of 2, it will be, it will not change, and here it will change. So okay, minus 8, so minus, so plus will be here. And what about the function itself? So here, so it decreases from -7 to -3 and from -3 to -1, and it so it decreases from -7 to -3 and from -3 to -1, and it increases from -infinity to -7, and from 1 to +infinity. How you have to write the final answer. So yeah, by the way, critical points. And here is the so maybe more convenient table. And how the answer must be written. So just showing these intervals. Stop. Stop. Something is not correct here, so yeah, I will have to double check it. So write in these intervals, and just don't forget that when writing when function increases or decreases, increases or decreases, don't forget just that these points are not included because either the function is not defined or or the derivative is 0. Okay. Any questions about this task?
No.
Okay, no questions. And now we need to examine concativity and inflection points of the following function. So this function x plus 1 multiplied by arctangents of x. So let me remind you that function is concave upwards or downwards when so upwards and downwards. So just if to explain like so geometrical interpretation, so some points, so when the function is concave downwards, we can put some liquids here. When downwards, we cannot. So like this. So, oh, stop. So the function is concave upwards when the second derivative is negative, and concave downwards when it's positive. So we need to calculate the first and the second derivative. So calculating the first derivative. So arctangents x of x plus the following fraction, but don't forget square here. And now we will differentiate it. So we're finding the second derivative. Differentiating again. So derivative of arctangents is the following, and plus derivative of this fraction. So this, and now, so x square plus 1, so multiplied by this derivative of this function, and minus 2x multiplied by x plus 1. By the way, let we find the common denominator. So let's transform it. Yeah, I can just do like this. So put 2 here. So found the common denominator and now expanding the brackets. So 2x square plus 2 minus 2x square and minus 2. Stop. Something is incorrect. Minus 2x. Yes. So now it's simpler. So eliminating 2x square, and we will just receive 2 by 1 minus x. Yeah, so it matches. And now we need to investigate. So now we need to investigate the function. So we need to solve this equation. So when y prime twice equals 0, and basically it equals 0 only if x equals 1. And by the way, this function, the denominator never becomes 0 because x squared plus 1. So this is the only critical point, x equals 1. So with using interval method, having the following. Only 1 point. So 1. So y prime twice and y. So now when a function, when it is greater than 1, what do we have? Minus, and when less than 1, it will be plus. So so the function is concave downwards from minus infinity to 1 and concave upwards from 1 to plus infinity. And how it is written here. Yeah, and by the way, what x equals 1 is the inflection point. So the point when the function concavity changes. Any questions about this task?
No questions.
Okay, no questions. So now let's have. Oh, by the way, what we solve task number 6, at least 1, and after that we will have a break for 5 minutes. So here we will not use differential calculations. So we will not differentiate functions, but we will calculate limits of these functions. So asymptotes. So basically, which asymptotes what is the asymptote? Asymptote is the straight line to which the graph of the function approaches. So just remember asymptotes of hyperbola, that hyperbola always approaches asymptotes, but never intersects, never touches, and so on. So what about vertical asymptotes? Vertical asymptotes are we can have vertical asymptotes when function has the discontinuity points of the second kind. So which second kind discontinuity point can be? X equals -5. So let's investigate this discontinuity point. So if I substitute, so 15, stop. 75 plus 5, so 80 plus 2. So basically this is infinity. Equals infinity. -5 minus 0, by the way. Yeah, if -5 minus 0, so minus infinity. And -5 plus 0 will be plus infinity. But anyway, stop. Yeah, everything is correct, but sign were not changed, so just duplicated. So, so what about the vertical asymptote? We have one vertical asymptote, x equals -5. And now let's investigate if the function has I forgot it how to oblique asymptotes. So oblique asymptotes are such asymptotes like so if we which have slope, and also the partial case is a horizontal asymptote. How to find oblique asymptotes? So doing the following. So we calculate the following limits when x approaches infinity. So f from x divided by x. So we calculate the slope of the asymptote, but oblique asymptote doesn't always exist. It exists always only if k is finite. So when this limit is not infinite. So basically we can so we know the highest degree. Highest degree is 2. So what we skip moving x square out of brackets, so we know that it is equal to 3. So, and now we need to calculate b. It is the following limit as well on infinity f from x minus kx. So, calculating the following limit. So, minus 3x by this denominator. And by the way, we can eliminate these brackets. So what we will receive. So let's expand. What's going on? So 3x in power of 2. Yeah, expanding these brackets. Minus 15x. So simplifying the expression. So 3x squared goes away. And we have minus 16x plus 2. So obviously it limits minus 16. So y equals 3x minus 16 is an oblique asymptote. So let's build the graph and check it. So firstly, we need, so it's a good idea to firstly draw asymptotes. And it's better to, yes, to use such a dashed style. So x equals minus 5. And then the oblique asymptote. 3x minus 16. And again, set in dashed straight line. And the graph of the function. So 3x square minus x plus 2 divided by x plus 5. And here is the graph. As we can see, it approaches asymptotes but never intersects with them and never touches. Any questions about this task?
No questions.
Okay, no questions. So now let's have a break for 5 minutes, and then we will calculate minimum and maximum values of x of a function, and then provide a full function analysis. So now have a break for 5 minutes. continuing the lesson. So the next task is the following. So we need to find the biggest and the smallest value of the function on this interval. Let me remind you that so if the function is continuous at any interval, so it will approach minimum and maximum value at this interval segment and so on. So either on edges or somewhere in the middle. So if in the middle, it will be the critical point of, so it will be extremum of the function. So we need to calculate, so how to solve? We calculate the derivative of this function and check for which values it becomes 0. So for which values of the segment it becomes 0 derivative. So we calculate value function at this point and on edges of the function. Edges of the interval. So first of all, calculating the derivative. So 2x. Oh yeah, by the way, why? So now it is more convenient. So 2x divided by 1 plus x in power of 4 and prime. So what do we have here? Here will be just square. And now 2 by this multiplier minus so minus 2x by 4x in power of 3. So continue calculating, so simplifying everything. So 2 and minus 8 x in power of 4. So it equals the following. 2 minus 6, 8, 2 minus 6 x in power of 4. And let's move to out of brackets. Well, what we want, what we not solve this equation so that it equals 0. Let's just believe this information that this is the solution, and this point believes this interval. So 1 minus root of the first of the fourth power of 3. Just to save our time. So now calculating the value of this function at this point and on edges of the segment. So y from minus 2 equals minus 2 by 2 and 1 plus 16, so it equals minus 4/17. Y from 1/2 equals this, and 1 plus 1/16. So what do we have now? 1 divided by 17/16. It actually equals 16/17. Okay, and now let's calculate value of the function at this point. And 1 plus 1/3. So what we basically have, so minus this multiplied by what? 4/3. Okay. So minus yeah, and it equals minus root of the first of the fourth degree over 27. So let's compare this result. Basically, this is the maximal value. So it equals 16/17. And what about minimum value? So let's compare. So it equals something about -1. So it is greater than -1, and it is definitely larger than -1. Or it is less than -1. So this is the minimum value. And by the way, if we just calculate them, so minus 4/17 and minus 3, no, damn it, minus 3 in power of 1/4. So this is the minimum value. Any questions about this task? Okay, I guess that no questions. So now let's continue. Let's investigate functions. So now we need to provide a complete analysis of these functions, of this function. So how it must be provided? The step by step. Okay, first of all, let me write the function, initial function 2x multiplied by x square minus 1. So firstly, we check the domain of the function. So the full answer will be the following. So and the domain, reminding you, so values of x for each this function is defined. From the function, we can see that it is continuous it is continuous on its domain except points -1 and 1. So the domain is the following: from -infinity to -1, and then united with -1, from -1 to 1, and from 1 to +infinity. So this is the domain of the function, so where it is actually defined. Then we need to find an intersection with the coordinate axis. In our case, so it just f. So in our cases, it intersects with the beginning of coordinates. So with point 0, 0. So just we can see that y from 0 equals 0, and so for intersection points with the x, we need to solve the equation y equals 2, and for intercept with y, we just need to substitute 0 instead of x. But in our case, we can see that it intersects with the beginning of the coordinates. Then we need to determine if the function is even or odd. So substituting -x instead of x. And what will we see? -x. So writing everything in details. So it equals -2x, and here x square -1, and let's move x out of let's move minus out of fraction, and what can we see? That it equals minus y from x. So is this function even or odd? So what do you remember about it? Okay, let me remind you. So the function is even when y from -x equals y from x, and odd, parno neparno, when y from -x equals minus y from x. So is this function even or odd?
It is odd.
Yes, it is odd. And the symmetry relative to y-axis or beginning of coordinates. Well, okay, I will remind you, so for even function, graph is symmetric with respect, so relative to y-axis. If odd, it is symmetric relative to beginning of coordinates. So this is the answer. Then we need to define it is if it's not if it's periodic or not, and Can you answer if it's a periodical function or not? What can you
It
say?
is.
Sorry?
It is.
It is. Do you think that periodical? But why? Well, the function is not periodical. We can just understand it from the expression of the function. So, what does periodical mean? That function has so function values are repeating with some period. So which functions are periodical? Trigonometric functions and some expressions that contain trigonometric functions that can be periodical. But this rational fraction is not periodical. You can just write that it is obviously not periodical. And that's it. And now we need to define, so we need to examine monotonicity intervals. For this, we calculate the first derivative. So 2 by this expression minus 2x multiplied by 2x. Power of 2. And that's important. So minus 2 minus 2x in power of 2. And by the way, I can move 2 out of brackets. So 1 plus this x plus x in power of 2. So yeah, so it's correct. So and now let's check if if the derivative basically so when it becomes 0. So when the derivative equals 0, yeah, it's an interesting question because the derivative actually doesn't is not equal to 0 at any points because so the numerator never becomes 0. So it always decreases on its domain. But just we need to mention that x equals -1 and x equals 1 are critical points. Yeah, by the way, it is always negative. So function is decreasing. So done with the monotonicity investigation, but yeah, it will be a good idea to provide such a scheme just to, for better demonstration, just also not to make you confused. So it will be useful. So the function is always decreasing. So now we need to investigate concavity of this function. So we need to find the second derivative. Moving to out of brackets for now, out of this fraction. What we have here, power of 4. And now differentiating 1 plus x in power of 2. So 2x multiplied by, yeah, don't lose powers. They don't like when you use them. So 1 plus x in square. Well, let me move to the bottom. So 1 plus x square and the derivative of this expression. So multiplied by 2x square minus 1 and multiplied by 2x because this is a composite function. Now we can cancel. So we can eliminate some powers. So one here. This goes. Oh, stop. So 1 power 1 here. This multiplier goes away, and power of 3 here. So it will be a little bit simpler. Then expanding brackets. So 4x in power of 3 minus 2x. And then, so here just 4x. Yeah, and let me move it here. So minus 4x and minus 4x cube. So what do we have now? Cubes are reduced. And here we have 16x. Oh, stop, not 16, 12x. Now stop, 8x here. Now what's going on? I lost 2 here. Or not? Yeah, I lost it. So here is not correct, but we solved correctly. And now we need to investigate it for 0. So obviously the second derivative will become 0 when x equals 0. So 0 is the inflection point. Oh, no. So no, first of all, let's investigate the behavior of the second derivative, and then we'll say anything about inflection points. So first of all, critical points such as -1 and 1, don't forget about them, and the 0 is included. So y prime twice. So when I set 2, for example, it is positive. When I set 1 second, so positive here and negative here, -1 second here is negative, and here is negative as well. So plus here and -2. So minus here and plus here, so negative. So how the function behaves? So it is concave upwards when so on intervals from infinity, from -infinity to -1, and from 0 to 1, and concave downwards from -1 to 0, and from 1 to plus infinity. I will skip writing it here, but the full answer is like this. So where it is concave upwards and downwards. And x equals 0 is the inflection points. Okay, and now we need to check asymptotes of the function. So let's do it. So remember that we need to calculate limits. So first of all, so what about vertical asymptotes? So we can see that -1 and 1, so x equals 1 and x equals -1 are possibly vertical asymptotes. And we need to verify it. So it equals so -1 here, and so -1 -0. So it equals -infinity. And what about +0? It will be equal plus infinity, but anyway, these limits are finite, so we know that it is a breakpoint of the second kind. So let's check these. So 2, and here, so here it is -infinity, and here plus infinity. Okay, or maybe, yeah, yeah, I confused a little bit. So here, no, everything is okay. Yeah, okay. So found the horizontal asymptotes, so vertical asymptotes, x equals -1 and x equals 1 are vertical asymptotes. So done. And now building the graph. Oh, no, not building the graph. Let's investigate for oblique asymptotes. So divided by 2 by x. So it equals 0. So it means, so k equals 0, so it means that we have a horizontal asymptote. And now let's calculate b. So just for not to miss details, so minus 0x. And what do we have? So actually, yeah, let me write like this. So we can see that b equals 0 as well. So y equals 0 is a horizontal asymptote. So asymptotes found. Yeah, now when found all asymptotes, we can start building the graph. Okay. So first of all, drawing asymptotes. And y equals 0. By the way, I don't mind if you use Desmos or any tools for building graphs, but you must mark, so you must mark, draw all information that you have here. So everything. So all points, all asymptotes, and so on. So the graph is the following. So 2x divided by x square minus 1. So we can see that everything is correct, so it approaches asymptotes, and the graph is always, so the function is always decreasing. So we can see it, always decreasing. Now what about inflection points? So we have one inflection point. Yeah, by the way, you also need to mark here intersection points with the coordinate x's, but we have only 1 point. So 0, 0. And this is the intersection point of the graph. And also it is the inflection points. But always you need to write extrema. So intersection points with the coordinate x's, extrema points, and inflection points. So here, inflection point and the intercept, they just match. So basically that's it. So all information must be on the graph. So you can either either draw it with your hands or with using program tools, but with all information. Any questions about this task?
No questions.
Well, actually, we have done everything that you had to do, that we had to do today. Maybe any questions about this lesson at all, or for previous lessons? Other questions?
Can you publish the file of this practical lesson?
Publish video, or you mean the so window?
Yes,
Correct.
this file, yeah, I mean that.
Okay, well, you have this file on DL, but I will also correct some mistakes, yeah, when I have time, and I will publish. Okay, more questions? Mikola, you raised your hand, or you were asking? Mikola, I don't hear you. You can write in the chat. I don't hear you, or you can write me in Google chat after that. So if no questions, Maxim, your question?
Yes, and when will you open the test for this module?
Yes, I will do, of course. Mykola, you have a question with the homework. Okay, please write me in Google Chat. So, or Gmail, but Google Chat is preferred. It is more convenient for me. Yeah? More questions?
No
Okay.
question.
Okay. Okay. So if no questions, have a nice day. Stay safe. And good luck on exam. And send all your homework, check it properly, and send it in time. So goodbye, everyone. Thank you for your attention.
Thank you. Goodbye.
We'll see you
Thank you,
in new
goodbye.
season.